So for a while I've been showing off various programs and tools that I've been developing as well as collaborating with others to develop to help make the process of designing circuits, troubleshooting circuits, and overall developing redstone circuits in general just a little bit easier. I've also been saying that at some point or another I'd be getting around to releasing these so that you guys can benefit from these tools, but evidently I haven't gotten around to it in a fairly timely manner. However, today I decided I would correct that and finally release something that I said I was going to release. Now, I could have released each of these individually as their own product and just sent them out onto the world as is, but truth be told, all of these things I actually use in conjunction with each other. They are kind of a kit. So I decided I would just release them all together as one big kit, something that you can download once and have everything you need to hit the ground running. Ladies and gentlemen, without further ado, I present to you the Redstone Development Kit, Release 0.1. To download the Redstone Development Kit, simply go to my GitHub page, link will be available down in the description, and scroll down to the 0.1 release. There you will find a .zip folder that you can download labeled Release 0.1. Go ahead and click that to download it. Windows may pop up saying that it doesn't like this download, that there might be some Trojan or viruses inside. This is not the case. If you're uncomfortable with the software and you think that there might be something Trojan-y or virus-y located in it, you can view the source code. That's why I put it up on GitHub. Windows is only saying this because I am an unlicensed software developer. It doesn't know who I am, therefore it doesn't know what the program is, so it thinks it's a virus. I promise you everything in this folder is safe. In fact, I will be using all of this stuff on camera myself so you can see exactly what it does. Now, if you extract this zip folder, you will find three components. The first is the Redstone Logic Analyzer executable, the second is the Redstone Structure Generator executable, and the third is the Redstone Development Kit datapack. Go ahead and load the datapack into your Minecraft save. This will give you all the tools you need to interface with these executables. And with all that, you should be set to start using these tools. The first tool we're going to take a look at is the Redstone Logic Analyzer. This is a tool used to examine the timing of various redstone signals after they've already been run. This is useful for troubleshooting complex or complicated circuits, but it can also just be used to generate timing diagrams for documentation. To use the Logic Analyzer, you will first need to create a probe or a set of probes. To do so, simply open up your world, stand in the location where you want to place the probe, and type the command function probe bit create. You can also type function probe word create, and that creates a different kind of probe, but we'll get into that here momentarily. Now, it's important that whenever you create a probe, you must be standing over redstone. At this point, the probes don't recognize any other kind of block, neither a repeater nor a comparator or a lamp or anything like that. That is something I intend on changing in future versions, but for the time being, these probes must be placed on redstone. Anyway, to create a single bit probe, which is just a probe that measures the state of a single redstone line, simply type function probe bit create, and you will see this nice little button appear in your chat. If you click it, Minecraft will suggest a command for you to run. This is the command that you're going to execute to summon the probe. And now before you execute it, there are a couple of placeholders that you need to fill in. If you look through the command, you might find custom name equals place name here. Where that place name here placeholder is where you want to place the name of your probe. Make sure the name is something that makes sense because this is a name that you're going to use to reference that probe in future. Once you've given the probe a name, go ahead and hit enter and the probe will be summoned where you stand. If you wish to destroy a bit probe, simply type the command function probe bit destroy. A button will appear in the chat, click it and the game will suggest a command for you to run. Much like the summon command, this is the command that you will run to kill any armor stands that are acting as probes, but you'll first need to place a name where the placeholder place name here is located. Replace this with the name of the probe that you'd like to destroy and hit enter. Now sometimes you don't just need to know the state of a single redstone wire, but in fact the state of a group of redstone wires. For this we have a different kind of probe, which I've called a word probe. To summon this, once again you're going to stand on a redstone line and type the command function probe word create. It's important when summoning this command, however, that you stand on the least significant bit of the bus that you're trying to probe. Now, once you execute this command, you will get three prompts that appear in the chat. The first prompt says summon LSB probe. Click this and the game will suggest a command for you to execute. Once again, you will need to name this probe, so be sure to fill the place name here placeholder with the name of the probe that you'd like to use. When you hit enter, the first of the many probes that you will be summoning will be summoned to your position. Next, click the next prompt, which reads initiate LSB probe. The game will suggest a command, and before executing it, you'll want to replace the place name here placeholder with the name of the probe you just summoned. Next, go to the next bit in the bus. Click the third prompt that says summon secondary probe, and the game will suggest another command to run. Here you've got two placeholders that you need to fill. The first is the name of the probe that you had just summoned, and the other is your name, or your in-game name. Replace these and hit enter. You're then going to repeat these steps for the remaining bits in your word. It's important that you start with the least significant bit and work your way up to the most significant bit and operate in that order. And it's also important that you don't exceed 32 probes. If the bus you're trying to measure has more than 32 bits, well, that might be a problem. At this point, my data pack nor my program actually supports any integers that big. It may be something that I'll try to support in future versions, but for now, just leave the probe size at 32 bits or less. Now, if you wish to destroy your word probe, unfortunately there is no command for that yet. You will have to wait for the next release. Now let's start collecting information for the logic analyzer. Type the command function logic analyzer commands start in the chat, and you'll immediately start to see information being spit into the chat. What these probes are doing is they're monitoring the redstone line that they're sitting on and waiting for a change. If they see a change, that change is reported in the chat. Now, we put this in the chat for a good reason, but we're going to go over that reason here shortly. When you feel that you've collected a large enough sample, go ahead and run the command function logic analyzer commands stop, and this will stop the probes from spitting any more information into the chat. It's also important that you run this stop command before running the logic analyzer program. And the reason why is because that stop command actually signals to the logic analyzer where it should stop looking for information in the chat. With your data collected, you're now ready to use the logic analyzer executable. Go ahead and double click it, and if Windows complains that it's an unverified publisher, just go ahead and hit OK. If you're, again, uncomfortable with it, just don't run it in administrative mode. You should see a terminal window pop up, and it may take a while for it to do something, but after a second or two you should see a message pop up that asks for the location of latest.log. By the way, if you're concerned with the program taking a long time to start running, that's just because this whole program was written in Python. In order to execute Python code, the Python interpreter must first be loaded, and that's what it's doing during that blank time. Anyway, the reason why we had all that information put into the chat is because that chat gets saved to the log in the Minecraft folder. Accessing latest.log will give us that information, and that's what the logic analyzer program will actually parse to pull that information. Go ahead and give this program the location of latest.log. You can either type it out, or I prefer to just click and drag it. Then hit enter. The terminal will now ask you for the names of the channels that you wish to render. You can leave this blank, in which case the program will just render any and all channels that it finds in any particular order. However, if you want to omit certain channels, or if you want to make sure that certain channels are in a particular order, this is where you have the opportunity to name that order. Simply type the names of the probes that you want to appear and in the order that you want them to appear in, and separate them with the pipe character. This is why I recommended naming all of your probes something that you could easily remember. For now, I'm going to leave it blank, but we'll run this again and show you what it looks like if you want to specify channels and their order. Go ahead and hit enter, and you should now see a message appear in the terminal, as well as an image appear in the folder. The terminal, of course, is just going to tell you that the generation has completed. However, if you had specified any channels that the render was unable to find or had a problem parsing, it will give you a rundown of the channels that failed to render. If you hit enter another time, the window will automatically close, and you can now take a look at the brand new logic analyzer render. So here you can see that every probe that I placed into the world is showing up in this render, and the order was determined by the logic analyzer program. If I wish to specify the order in which these channels appear, or I wish to only render a subset of these channels, I can again specify this with the logic analyzer program. So if I go ahead and type out the names of the channels that I want rendered in the order that I want them rendered, and hit OK, we should now see that the image shows these channels and only these channels in the order that I specified. Now, the next tool we have in this kit is the Redstone Structure Generator. This is a tool predominantly used to generate procedurally generated circuits, or just circuits that can't be made by copy-pasting a section in a world editing tool. Currently, the Structure Generator tool supports 3 different structures. The first is a basic encoder, and the next 2 are 2 variants of a decoder design. The reason why there are 2 decoders is because one of the algorithms is optimized for speed, while the other is optimized for space. To use the Structure Generator, simply double-click on the executable and wait for the Python interpreter to load, and after a brief moment it should prompt you with a question like, what kind of structure would you like to build? Here you can type in the name of one of the 3 structures. Let's start with a basic encoder. Simply type in all lowercase basic underscore encoder, and you'll get this prompt. The program is now asking you for the source file. Basically, the basic encoder program is going to take in a list of 1s and 0s representing a table and translate that into a redstone circuit. So we need to provide a list of 1s and 0s that it can turn into said circuit. I have a pre-made pre-made table here, which I've called encoder.txt. And if we open it up, you can see a bunch of ones and zeros arranged in a grid. We can see it's 5 lines, and each line is 9 bits long. So this is going to produce an encoder with 5 active low inputs and 9 active high outputs. You can think of it like each line being a line in an encoder, and when that line is active, that number on that encoder line is going to be presented at the output. The outputs are going to appear as they appear in the text from left to right. However, the structure will build this with the top line in the text file being built closest to you, and the bottom line in the text file being built farthest away. You can use any text file, of course, as long as it contains this structure of ones and zeros. But for demonstrative purposes, I'm going to just use this. The next thing the program is going to ask you is which direction are you facing? This is important because the structure is built relative to you in the game. So if you want the structure to appear in front of you, you need to tell the program which direction you're facing. Valid inputs are north, south, east, and west, and you can get this information from the F3 menu in Minecraft. The next argument is input side. When the structure is built, the outputs will always face you. However, the inputs can either come in from the left or the right. Getting this right isn't too terribly critical, but it can save you some hassle as it does place the repeaters in the correct direction. Next is the build to argument. Since this structure is being built relative to you serve as one of the corners of the structure. Valid inputs are, of course, left and right. If you choose right, you will serve as the left corner, and if you choose left, you will serve as the right corner. The last argument is offset. These are just 3 signed integers separated by commas, and this will allow you to offset the structure from your position. So if I enter an offset of -4, 0, 0, this will shift the entire structure back 4 meters on the x-axis. Likewise, an offset of 0, 1, 3 will shift the structure up 1 meter on the y-axis and 3 meters over on the z-axis. Transformations are always applied after rotations, so the direction you face will not affect these coordinates. Once you've entered all your arguments, the program will get to work compiling all the commands needed to be run to generate the structure. When it's done, it will prompt you with a done message. At this point, the program is ready to begin building, but it has not begun building yet. You need to press enter in order to initiate that. Before you press enter, make sure that you have your game running and that you are standing in the correct position. Remember, the structure is built relative to your position and you cannot stop it once it starts. Press enter and a 5-second countdown will begin. Use these 5 seconds to tab into your game, get out of the pause screen or any GUI that you are in, and then simply wait for the generator to start. Once started, you will begin to see commands being typed into your console and the structure will slowly start to take shape. While this is happening, it's important that you don't tab out of your game. Doing so will cause the commands to be typed elsewhere and the structure will be corrupted as a result. Wait for the generator to finish typing, and once it's done, you can press enter to exit the console. Let's take a look at generating decoders now. We have 2 algorithms for generating decoders. One is referred to as the proper English 19 decoder, and the other as the Stenedian decoder. The process and arguments for both of these decoders are exactly the same, so we're only going to cover one. However, if you want to know the difference, the proper English 19 decoder will generate a smaller decoder, but will take longer. Whereas the Stenedian decoder will generate a decoder that's slightly larger, but it will do so much faster. Let's create a proper English decoder here. I'm going to type proper English 19 decoder to get the process started, and the first thing it's going to ask for is a source file. For demonstrative purposes, I'm going to be using this pre-made source file here called decoder.txt, and if we take a look at the contents, we can see a grid of 1s, 0s, and x's. Running this through the decoder generator will produce a decoder with 9 active high inputs and 5 active low outputs. You can think of each line in this table as the line that will be activated when a particular sequence of inputs has been met, and that sequence is determined by the string of x's, 1s, and 0s that you see at that line. Now again, the inputs are going to appear on the circuit as they do in the text file left to right, but the outputs are going to appear with the top line appearing closest to you and the bottom line appearing furthest from you. I'll go ahead and add this file to the generator as an argument and hit enter. And it's going to then ask for a facing direction. This is exactly the same as the encoder. The decoder is direction dependent, so you'll want to tell the generator which direction you're facing in order for the decoder to be properly generated. The next argument is the output side. Again, much like the encoder, the decoder's inputs will always face you, but the outputs can either go to the left or to the right. Specifying this will make sure that all the repeaters are in the right direction. Next is the build to argument. Once again, the way the structure is generated is it basically generates the entire thing around you, with you serving as one of the 4 corners. Now you can either serve as the left or the right corner, and you can pick this by putting in left or right in as this argument. Typing right will make you the left corner and will build the structure off to the right. But you should know this already. The last argument is the offset. This works exactly the same as the encoder, so we're not going to go into this too much. Once again, make sure your game is open and ready, get yourself into position, and hit enter. The countdown will begin, and shortly after, the structure will start being generated. Once again, don't interrupt this process, otherwise you will screw things up. Just wait patiently until the structure is done. If you're curious how long you have to wait, of course, the console will be spitting out how many commands it has typed up and how many it still has to type up, so that will give you a rough idea as to how long you will be sitting there. And that's pretty much all you need to get started. If you're curious, by the way, the GitHub page will have documentation for all of this. Simply go into the folder of the application that you wish to learn more details on, and you'll find a README at the bottom. And with that, you should have everything you need to get started with this toolkit. Now, I know there isn't a whole lot, and quite frankly, there is plenty of room for expansion with this kit. Quite frankly, I also have a ton of ideas for which direction this kit could go in. But I figured I'd release it now. Sooner is probably better. One, you get a nice toolkit that you can use now, and two, it also gives me an opportunity to get some feedback from the community to see what you guys think should be included. Anyway, I hope this helps, and if you have any questions, feel free to leave them in the comments, and happy building!